All right, our next presenter is Dr. Bryan Wang, Associate Professor of Advertising and Public Relations at the University of Nebraska, Lincoln. Take it away.
Thank you. Thank you, Valerie and Lisa, for the introduction. Today, I will talk about the two projects I've been working on regarding vaccine misinformation on social media using mainly computational communication methods. The majority of the content studies on vaccine miscommunication and misinformation are based on Facebook, Twitter, to a large extent because these platforms offer user-friendly and open API and very easy to get access to these data. But there are a lot more platforms in the social media space. Here, I highlight two recent trends. One is the rise of visual communication on sites like YouTube, Instagram, TikTok. And also, the other trend I wanted to mention here is the growth of an alternative social media ecosystem, such as Telegram, Signal, and Gap. And so here I talk about kind of two projects looking into each of these areas. So in a 2020 article in the American Journal of Public Health specifically called for more research on health misinformation on YouTube, Instagram, and TikTok, these emerging media. So to answer this call, I collected visual and analytics data from Instagram, TikTok, and YouTube as well. The YouTube data is now reported here. One set of data focused on HPV vaccine-related content, and another set of data focused on misinformation hashtags about COVID-19 vaccine. And so from theories, we know that emotions are very powerful triggers of viral communication. And we know that negative emotions tend to be more powerful. So kind of hypothesize that negative emotions would be very effective at triggering viral communication. And also, I draw down research on emotions. The current research on emotions typically employs either a dimensional approach, such as positive and negative valences in sentiment analysis, or a discrete emotions approach, so looking specifically at fear, anger, for instance. So far, few empirical studies have looked at mixed emotions. Manual coding is very hard to get reliable estimates of mixed emotions. So in this study, I offered an AI-driven computational solution. I ran all the images and video screenshots through a computational visual analysis program that assigns a value for the likelihood of the presence of each of 7 discrete emotions plus a neutral category. So the results show that happiness was the most dominant emotion in vaccine misinformation visuals, followed by the neutral category, which was kind of different from what I expected. Amongst negative emotions, the most prominent negative emotion was actually sadness instead of fear that we typically hear in the literature. I also regressed virality measures on, and also mixed emotions are very common, emotions where we feel multiple discrete emotions at the same time. And also I regressed virality measures such as likes and comments, number of likes, number of comments on different type of discrete emotions, and found that high arousal emotions tended to predict viral communication, which is what the literature expected. What I hope to do next is to build a custom training data set with these visuals to develop a machine learning algorithm that can detect future images that contain vaccine misinformation. Another development in the misinformation environment is the emergence of an alternative social media ecosystem. As a result of misinformation crackdown on major social media platforms such as Facebook, Twitter, and YouTube. So these platforms have removed content and accounts that spread misinformation, a practice called deplatforming. As a result, these users are migrating to an alternative ecosystem, such as Telegram and Gab. So I identified and collected posts and shared links in 8 anti-vaccine groups and channels on Telegram that reached more than 200,000 users. And so theoretically, I wanted to test the network media system involving mainstream legacy media, mainstream social media, and alternative social media. So I conducted 2 types of analysis, one looking at extract URLs, another I did a topic modeling analysis. So the URL analysis showed that there was actually a filter bubble, echo chamber, however you want to call it. There's a lot of interest sharing, meaning sharing of internal links. I also found a lot of sharing of mainstream social media sites, but not many legacy social media sites. And so the ecosystem is still connected with the mainstream social media, but very removed from the legacy media. Misinformation from fake news sites, far-right extremist sites, and news sites are also very popular. A study also did a latent Dirichlet allocation algorithm to look at the topics, and I found vaccine victim deaths and vaccine safety were top thematic themes in these data. Thank you.
Wow, Bryan, that was amazing because my timer dinged right at the word.
I was timing it myself too, so trying not to run over time.
I guess I had my doubts about, I thought we were going to have to be, raising the music like at the Oscars and like dragging people off of the screens, because we know how we academics are. But you all have been very, very attentive. I'm impressed. All right, Dr. Jamison Hayes is next, Associate Professor of Advertising and Director of the Public Opinion Lab at the University of Alabama. Jamison, you're on.
Okay, thank you so much, Valerie. We really appreciate you having us. And I am going to quickly talk about one of the this one we're actually going to present at ICORIA in Europe next month. But I am the director of the Public Opinion Lab. You've heard from Dr. Britt, and we're now starting to get social media data with our biometrics capabilities at UA as well. So this is kind of our first entry into that space and trying to work with that. So this one's called Consumer Brand Engagement and Social Media Influencers, particularly how do mommy influencers use emotion and discrete emotions to influence their audiences. Really quick, I am not the sole author on this. Actually, Dr. Stephen Holliday, who couldn't be here today, is the lead author of several multiple really great doc students. A couple of those are now who are working on this. Really what we wanted to understand here was how do influencers use multimodal emotional communication for persuasion. So you watch, and mommy influencers tend to use their children. They tend to use emotional appeals. How does that emotion drive how people engage with Instagram posts, essentially, is what we're looking for. So first, how does that multimodal emotion impact engagement, and how does the influencer network size moderate that? So if you have a micro influencer that only has a few, or a smaller audience, a smaller network size, how does that impact its impact on engagement differently than, say, larger level influencers? And also we also looked at how branding alters that. So when a brand's involved, how does that kind of impact those relationships as well? So really quick on methodology, we have 2 on this. So what we use a sprinkler in this case, actually, although we use sprinkler in the lab quite a bit. We use CrowdTangle to select over 5,000 Instagram posts from the top 50 Instamom, micro, macro, and mega influencers. We 102 videos off the top that were branded. The rest were unbranded videos. So these are videos that brands actually paid for. And we put those in the sample, and then we took a random 300 of each micro influencers, 300 influencer videos, and added those to the sample. Then our data processing was kind of twofold. First, we wanted to understand emotion communicated in the videos themselves. So we use facial expression analysis, Affectiva Affdex, which is part of our motion suite. So we pulled the videos from CrowdTangle, we captured those, we ran those videos through this facial expression analysis to measure the emotion used in the actual video content. And then we took the text and we did computational text using LIWC, which is linguistics inquiry and word count, which measures psychometric values of text used in social media as well. So from that, for emotion, discrete facial emotion in the video, discrete textual emotion via LIWC. We use follower count, which was which we got from CrowdTangle, and branding from CrowdTangle, and all of those were in our model. Those came from 3 different sources, but we were able to use them as IVs, and our dependent variables became likes, comments, and views. So how do all those things impact how people actually respond to those videos, Instagram posts, and social media? In terms of data analysis, we use negative binomial regression. We'll talk a little bit more later on today about things you have to look at for what sort of analyses you need to use based on the structure of your data. Social media tends to give you some very interesting keys, which means you have to enter some different analysis approaches rather than just your standard multiple regression. We use spotlight analysis to understand those effects at one standard deviation above and below the mean to kind of probe interactions. And our big takeaways were that one, emotion is more persuasive for larger networks than smaller networks. So macro influencers can use emotion more so than micro influencers, but micro influencers work better if they use negative emotion. This is because they haven't built up enough goodwill to just use positive emotion and drive engagement. People want to hear real information, real opinions from the micro influencers, and that tends to include them with things like sadness or things they engage with. So next steps, we're going to bring mothers to the lab and show them the videos and see how the consumer responds to this. And I believe that is my 5 minutes.
Nicely
Perfect.
done.
You have 2 seconds left.
Oh. And for a Southerner, that'd be like one more word, or no? I'm just giving you a hard time. Awesome. Thank you so much. And yes, you can hear more about some of those things this afternoon in Jameson's next session. And we have Dr. Ashok Samal, professor in the School of Computing at UNL.
Good morning, everybody. My talk will be very different from everybody else's. We're not really looking at very specific problem, although we are actually looking at a couple of things, but not yet with social media. So we are, some of my research interests are in spatial data mining, so things that have got spatial coordinates and understanding how things happen in space. So we are interested in sort of two particularly interesting social processes. One is social unrest with my colleagues in sociology and with climate science, and my colleague at the Citadel, trying to understand how things evolve and to if you can predict where social unrest are going to happen and when. And we are right now more focused on extracting information from the newspaper data, extracting the journalistic 5 Ws, who, when, where, what, and why. But we would like to sort of go beyond that to social media. And I'll talk briefly about some challenges. But also I was going to quickly mention that one of the things I tend to do is before I do something in terms of research, I give some of the problems to my students in my classes I teach. So I teach a course in data mining this semester in spring, and I'm going to briefly talk about a couple of interesting projects that presented this week on Tuesdays and Thursday. So I'll talk about that briefly, and then talk about some of my challenges and what kind of things that. So this group wanted to look at sentiment analysis in space, and people who tweet about UNL in their tweets, and they did. They started with sprinkler, but found not quite as effective in terms of one of the things I tell in my class is that if they want to do a project, they must at least have 1 million+ transactions. So they have to have very large amount. So they just couldn't get quite that much with sprinkler in an easy way. They found other ways to scrape millions of tweets, and then they found lots of interesting things. They did some spatial clustering, sentiment analysis, all those kinds of things. Of course, they found some interesting clusters. So if you see, these are not surprising. These are the 3 campuses of University of Nebraska. That's Omaha, that's Lincoln, and that's Kearney. So that's not, but they also did, they found that the sentiments are really not that interesting. They're mostly neutral, but they found some interesting clusters of people who tweet about UNL from Western Europe and Asia and so on. That could be interesting. So that's the other group that did that. They, for whatever reason, I give them some topics I'm interested in, but they end up doing what they want to do. So they want to look at whether people who follow QAnon, they believe or don't believe in climate change and so on. So they did, again, they did use sprinkler, but they didn't quite have as much. They had to do things manually quite a bit, which was a problem, but that's what they did. So they got these tweets and about, they did a keyword-based things with, to get QAnon tweets. They built a classifier to see if they are deniers or they, climate change deniers and so on. And they built a, from scratch, a multinomial Bayesian classifier, and they have to train and all that stuff. They built a classifier that is about 80% accurate. And this is what they found, that there is a significant difference in how people who follow the Q think about climate change, and the people in general, how they feel about climate change. So there is that's there. So just very quickly, I was going to say in terms of the kinds of things that we would like to do, and where we find some challenges. One is the sprinkler. We can download only 10,000 things, and so if you're dealing with very, very large numbers, because for us, it's not really as focused on very specific problems. We're basically interested in algorithm development. So bigger the data set, it's better. Deep learning requires that we have a lot bigger data sets. So we would again, we thought about can we train a classifier to see if the images are people present in social media are relating to social unrest. And to do that, we need lots and lots of images to train. And then that's been also a challenge. And finally, as I mentioned, we right now are looking at spatial unrest from newspaper data and getting large volumes of newspapers from different areas are also a challenge. So that's all I have to thank you.
Thanks for letting me finally share the applause, Ashok.
That's great. And we wanted to hear from Ashok because we asked him to use this in his class and kind of give it a test, put it through the ringer. And so he's done that, and I see that Jameson has noted that you can use the Sprinkler API to download large data sets if needed. So that's something that that we can work on.
Yeah, I didn't know that we had access to the API, but that's good to know.
Yeah, awesome. Thank you so much. And this is that's the end of that kind of set of presentations. So we've got a little bit of time for Q&A.
Any panelists, any attendees, anybody want to raise their hands? Or Valerie, you can move on to the next set.
All right. We'll go on, and then we'll have a chunk of time at the end.